I'm Dr. Bruce Boman from the Helen F. Cancer Center in Newark, Delaware, and we have a paper that recently came out in Oncotarget. It's entitled Anti-Cancer Effect of Retinoic Acid Signaling in Colorectal Cancer Occurs via Decreased Growth of ALDH-positive colon cancer stem cells and increased differentiation of stem cells. So our research is based on the paradigm that colon tumorigenesis is driven by overpopulation of cancer stem cells. The research goes back to an earlier finding where we found that aldehyde dehydrogenase, or it's abbreviated as ALDH1, is an accurate marker for stem cells in the colon, and ALDH will track stem cell overpopulation during colon cancer development. So in this research project, what we pursued was that because ALDH is a marker and is expressed in stem cells, and ALDH is a very key enzyme in the retinoid signaling pathway, we investigated whether the retinoid signaling pathway was actually active in the stem cells. And indeed, what we found was that the receptors for retinoids, RXR and RAR, are selectively expressed just in the stem cells from the colon. And so that indicated that the signaling mechanism is going through the stem cells. So then we also looked at the other components in the retinoid signaling pathway in the colonic stem cells, and we found indeed the other components of the retinoid signaling pathway are present in the stem cells from the colon. Now, the stem cells in the normal colon are located and reside at the bottom of the colonic crypt, and they're responsible for producing all of the other cells within the crypt. And the crypt turns over about every 5 days. So it's a very proliferative subunit in the epithelium of the colon. So what's interesting is that retinoid signaling is based on retinoids, which are derivatives of vitamin A. And we know that vitamin A is essential for embryogenesis and early development of humans, and vitamin A deficiency can lead to lots of problems in development. So since development of embryos is highly dependent upon the stem cells within the embryo, we also figured that the retinoid signaling pathway was active in the stem cells from that standpoint. So we then looked at the colorectal cancers to see what happens with retinoid signaling components, and what we found was that the receptors RAR and RXR are overexpressed in the colorectal cancers as well as the other components of the retinoid signaling pathway. So this overexpression of the components of the retinoid signaling pathway occurred in parallel with overexpression aldehyde dehydrogenase as well as overpopulation of ALDH positive stem cells in colon cancers. So it appears that the overpopulation of the colonic stem cells in cancers occurs in parallel with the overexpression of the components of that signaling pathway, which suggests that retinoid signaling pathway, when dysregulated, contributes to the development of the colon cancers. So to test that, what we did is we actually treated the colon cancer cells in culture, the colon cancer cell lines. We treated them with retinoid derivatives, particularly ATRA, all-trans retinoic acid. And when we treated the colon cancer cells with this retinoid derivative, we found that it shut down the proliferation of the stem cells, it shut down the self-renewal of the stem cells, and it induced differentiation of the stem cells into neuroendocrine cells. So that shows that the pathway is in part responsive to the ligands that affect the signaling pathway itself. So we thought that was pretty exciting. So it kind of goes back to this being an accurate marker for colon cancer stem cells, and it begins to suggest ways that we might be able to actually target the stem cells in treatment of the colon cancers. In fact, our discovery of this pathway leading to increased growth of colon cancer stem cells suggests new possibilities for designing treatments for colorectal cancer. So that pretty much summarizes what our paper paper was about. Our future directions are to explore this pathway even further, because the real question is why the pathway is dysregulated in the colon cancers and how we might be able to reverse that dysregulation so that when we give the ligands, the retinoid analogs, to patients for treatment of colon cancers, how we might actually induce the cells to respond like the normal colonic cells would in shutting down their growth. We know that retinoids are very effective in some cancers. In fact, in some leukemias, like apromyelocytic leukemia, retinoids are actually curative in treating patients. So the hope is that if we understand how the pathway is dysregulated in colon cancers, maybe we can actually use the retinoid derivatives to successfully treat colon cancer patients. So that's what our future direction is. We all know that being able to shut down or decrease or kill colon cancer stem cells offers ways to target cancers, because if the cancer stem cells are driving the tumor growth, theoretically you're going to have to eradicate the cancer stem cells to cure patients, or at least shut down their growth so that they undergo apoptosis and stop growing in that way. So our research is really focused on trying to find ways to target the cancer stem cells through some of the pathways that are endogenous to the stem cells themselves. And we think our research offers great hope, because if this signaling pathway is actually selectively operational in the stem cells, perhaps it represents a target where we could give the ligands for the pathway in hopes that we could shut down the cancer stem cells and shrink tumors in patients.